Good evening. My name is V. Selvam, Assistant Professor in Mechanical Engineering. I discuss about the advanced internal combustion engines. Unit 4 Alternative Fuels. The following topics are discussed. Need for alternative fuels, alcohols, vegetable oils, biodiesel, biogas, natural gas, liquefied petroleum gas, and hydrogen. Manufacturing, storage, and safety properties, engine modification and emissions for performance, combustion and emission characteristics of SA and SAE engines. First, need for alternative fuels. Conventional fuels are going to run out. One day, our sources for traditional fuels, including petroleum, would be depleted, owing to the fact that these fuels are typical not renewables. To reduce the pollutions, the use of the alternative fuels considerably decrease the harmful exhaust emissions such as carbon dioxide, carbon monoxide, particulate matter, and surface dioxide, as well as ozone producing the emissions. To protect the against global warmings, according to commonly accepted scientific theory, burning fossil fuels was causing temperature to rise in the earth atmosphere, that is global warming. To save the money, alternative fuels can be less expensive to use, not just in terms of the fuel itself but also in terms of longer service life. This in turn means saving for the long term. Can reuse the waste. Biofuels, bioproduct, and biopower provide modern and fresh relevance to the old belief that a dress for one person is a treasure for another. That good news, considering that American produce in excess of 336 million tons of waste each year. More, more choice. People are different. Each person has his own requirement, opinions, and preferences. One great thing about the alternative fuels and the corresponding vehicles that run on them is that there is something to suit any lifestyles. Helping the farmers. The use of the biofuels that depends on crops produced and processed locally help to support the farmers for their dedicated and hard labor. Biodiesel and ethanol cooperative are the result of the great out model farmer um, cooperatives that assist with the retaining power the hand of the peoples can frequently be produced domestically. Often, alternative fuels can be developed domestically, utilizing the country resource and thereby strengthening the economy. The fuel economy. Vehicles driven on hydrogen fuel cells and diesel are more economical with respect to fuel compared to an equivalent gasoline vehicles, meeting current global energy demand. Alternative fuels are receiving attention because of the following reasons. Alternative fuels are mostly produced from domestic resources that reduce the energy depends. Use of the locally available resource for the fuel purpose can reduce crude oil import bills. Most of the alternative fuels, for example, alcohol, biodiesel, can be produced from biomass resource and agricultural waste, and the electricity for battery operated vehicles can be produced from solar and fuel cells. Parameters are to be considered while designing the alternative fuels. The fuel should have high volumetric and mass energy densities, easy of transportation from production site to delivery points, large storage life of the fuel, minimum handling and distribution problems, environmental compatibility. While using alternative fuel, the engine performance is expected to improve significantly with regard to regulate the emissions and unregulated emissions. Manufacturer warranty. The alternative fuel must guarantee the lifetime of the equipment, its reliability and operational capability are not modified. Investment cost. Additional investment on an existing engine must be small to ensure that the operation is competitive with the petroleum fuels. Alcohols. Alcohol is an attractive alternative fuels because it can be obtained from a number of sources, both natural and manufactured. There are two kinds of alcohol. They are methanol and ethanol. Methanol as the alternative fuels. Methanol is one of the most promising substitute for petroleum fuels. It can be produced from a wide range of available raw materials like coal, lignite, and municipal solid waste. Pure methanol and a mixture of methanol and gasoline in various percentage have been extensively tested in several engines and vehicles. The most common mixture are M85, that is the 85% methanol and 15% gasoline, and M10 means 10% methanol and 90% gasolines. Production of methanol from lignite or coal. The pulverized coal is feed into the gas fire where oxygen is supplied and combustion takes place. Synthetic gas, which consists of CO and H2O, is produced due to combustion of coal. All H2S and most of the CO2 are removed by processing amine solutions. The carbon monoxide react with hydrogen and produced methanols. The raw material is the purified to remove the waters. Methanol as alternative fuels. Performance of methanol. The, the performance of petrol, diesel, and methanol engines. It shows that pure methanol gas engine has about 20% greater output compared to that of the standard petrol engines. This is due to the higher compression ratio and more efficient thermodynamics process of methanol engines. Ethanol has been used as the alternative fuel for many years in various regions of the world. Brazil is probably the leading user, wherein the early 1990s 5 million vehicles operated on fuels that were 95% ethanol. For a number of years, gas call has been available at a service station in the United States. The most common mixture of E85 and E10. Production of ethanol. Ethanol can be produced from sugar or grain. In contrast with the methanol productions, the process does not require extreme temperature and pressure. Hence, very small unit is needed to produce the ethanol. Production of ethanol from sugarcane. The production of ethanol from sugarcane requires a simple process since the fermentable sugar is obtained directly from the sugarcane. Sugarcane is first cut and ground, and the cane juice is extracted. This sugarcane juice is then fermented with yeast to produce raw ethanol. Ethanol is produced by fermentation of carbohydrates by the gray Lusok reactions. Alcohol gasoline fuel blend. Alcohols cannot be used directly as the fuel in automobile engines, expected methanol in racing cars, but it can be used as blend with the gasoline. Some common alcohol gasoline fuel blended are E85, E10, M85, M10. The advantage of alcohols: high thermal efficiency, higher volumetric efficiency, good internal cooling. The alcohols can also be blended with the gasoline to form the gas called, and it is widely used in USA. Sulfur content in the fuel is low. less overall emission when compared to the gasolines. Vegetable oils as diesel fuels. Vegetable oils have two broad classification. Edible oils, there is the sunflower, soybean, palm oil, extra. Non-edible oils, then edible oils are mainly used for food purposes, whereas non-edible oils are used for food purposes. Vegetable oils can be used as the substitute fuel for diesel engine applications. Use of the vegetable oil for fuel purpose reduce the import of costly petroleum and improve the economy of agricultural countries. They are biodegradable and non-toxic. Vegetable oils are of low aromatics and low sulfur content and hence reduce the particulate matter emissions. They have a reasonable Seton number and hence possesses less knocking tendency. Disadvantages of vegetable oils in CA engines. The high viscosity of vegetable oils lead to pumping and automation problems in the normal diesel fuel injection systems. High carbon residues causes heavy smoke emission and carbon deposition on the injection nozzle tips and in the combustion chambers. There are also problems for incompatibility with the engine lubricant. The poor validity max valid volatility makes the vegetable oil difficult to vaporize and ignite. This leads to thermal cracking, resulting in the heavy emission and carbon deposit in the combustion chamber. This tendency is partly due to higher fuel viscosity. Biodiesel. Biodiesel is the one of the alternative fuels. And then this made from biological sources instead of petroleum. It is made from plant oil or animal food. Pure biodiesel is referred by B100 standard diesel usually mixed with biodiesel. 80% percentage of standard diesel is mixed with 20% of biodiesel. This blended biodiesel is referred by the B20. National Biodiesel Board, the technical definition of biodiesel is a fuel compressed at non-alkyl ester of long chain fatty acid from the vegetable oils animal fat designed B100 and meeting the requirement of ASTM D6751. Biodiesel production. Vegetable oil react with alcohol in the presence of catalytic production biodiesel. Biodiesel production process consists of three steps, namely conversion of triglycerides to diglycerides and one ester molecule, followed by the conversion of diglycerides into monoclystarides and one ester molecule. Monoclystarides into glycerol and one ester molecular catalyte. Advantage, it also safe and non-toxic. It has higher plug point and conventional diesel oil. It can be easily stored and transported. It can be also used to as engine lubrication assistant. It increases the engine life due to less deposit. It has lesser emissions. The below table gives average emission of biodiesel and compared composite diesel fuels. Disadvantages, NO emission will form smoke. All the biodiesel being solvent helps in better lubrication, yet the losing deposit from the conventional diesel engine compound may clog the fuel filter, so filter should be changed often. Cost of the biodiesel is more than the conventional diesel oil. Less availabilities. Biodiesel breaks down a rubber component. It does not suit all type of engine. In some engines, the reduction in power occurred at 10%. 1.1 liter of biodiesel oil would be equivalent to 1 liter of conventional diesel oils. Thank you.